Tidal heating, also known as tidal working, occurs through the tidal friction processes. Orbital and rotational energy are dissipated as heat in the crust of the moons and planets involved. The major heating source of Earth and its moon is radioactive heating, but the heating source on Io is tidal heating. As Jupiter is very massive, the side of Io nearest to Jupiter has a slightly larger gravitational pull than the opposite side. As Io is the innermost moon of Jupiter, Jupiter pulls Io inward and other moons pull Io outward. The distance between Jupiter and Io changes all the time, and the distortion of Io likewise changes all the time. The constant change in the shape of Io results in a large amount of friction in the moon, and the friction-induced heating drives strong volcanic activities on the surface of Io. Although there is general agreement that the cause of the heat as manifested in Io's many volcanoes is tidal heating from the pull of gravity from Jupiter and its moon Europa, the volcanoes are not in the positions predicted with tidal heating. A study published in 2015 explains the eastern shift by an ocean of molten rock under the surface. Liquids, especially if they are sticky, or viscous, can produce heat through friction. The team who wrote the paper believe that the subsurface ocean is a mixture of molten and solid rock. When the molten rock flows, it may swirl and rub against the surrounding rock, thus generating heat. Other moons in our solar system undergo tidal heating, and they too may have more heat generated by this process, including heat from the movement of water. This ability to generate heat in a subsurface ocean increases the chance of life on bodies like Europa and Enceladus.